Before we look at exact values for trig, I just want to practice using our three trig ratios, sine, cosine and tangent. If you feel confident with this, I should have put in the description below the timings, so jump forward to the first task and have a go with that. There's two levels for you to choose from. If it'll be useful to go through a couple of examples, I'll do two here and then I'll put two up for you to try. So if we start with this one, remember the first thing we do is to label the sides. So the opposite side is the one that's opposite the angle we're interested in. The hypotenuse is always the longest side, and that's always opposite the right angle. And then the adjacent side is the one between the right angle and the angle we're interested in. Now in this instance, we're not interested in the opposite. We know what the hypotenuse is, we want to find the adjacent. So we find the trig ratio with those, which is cosine. And remember how we can use the triangle. It's the adjacent we want. So if we cover that up, we can see that that's equal to the cosine of our angle, cosine of 50 degrees, multiplied by the hypotenuse. And if we do that to two decimal places, we get 9.0. And if you're not asked, given an amount to round it to in a question, two decimal places is a decent amount. One thing to be really careful with on this is when you type it into the calculator that you use the bracket after the angle, because it'll open it up for you. When you press cosine, it'll do that. If you don't remember to close the bracket, what it will do here is the cosine of 50 times 14. So it'll be the cosine of 700 it will be calculating. So just really watch out for that. On our second example, so labelling the sides, we've got the hypotenuse opposite the right angle, the longest side. Opposite our angle is 4, and this is the adjacent. So the two we're interested in here, we're told the opposite, we want to find out the adjacent. So for this, we need to use tangent. And it's the adjacent we're after, so that's equal to the opposite, 4 centimetres divided by the tangent of our angle, tangent of 30. And that comes to, on the calculator as you do it, comes to 4√3, which looks like the surds you did in your starter for practice. We'll have a look at why some of the answers come up like that sometimes, but if we put that in its decimal form for now, two decimal places, we'll get 6.93. Two questions here for you to try. Pause the video, have a go, and then come and check the answers. So here we've got the opposite and the hypotenuse. So we need to use sine for this. And our trig ratio tells us that the opposite is equal to sine of our angle, remembering to close the bracket on your calculator, multiplied by the hypotenuse. That comes to 2.62. Here we're trying to find the hypotenuse and we know the adjacent. So we need to use cosine for this. So the hypotenuse is equal to the adjacent divided by the cosine. And that gives us 15.66. Now, if you're not confident with this, it might be worth looking back at the trigonometry work we did before. I'll give you the date for that in the Show My Homework post, because it's really important to get this bit before we move on any further. But we've got a task coming up here to practice these skills. There's two challenges on this task, and there's a PDF copy in Show My Homework. The first one, the more straightforward challenge, is just finding the missing sides that we've got on the triangles here. So that's fairly straightforward. The second one, a bit more challenging, I really like it. So you've got to find the perimeter for each triangle, and we've got the answers down the right-hand side here. Now, you'll need to use some different skills for that. There's lots of trig in there, but you'll also need to use Pythagoras on some. So think carefully about how to do that. You'll know you're on the right track because you should spot each of these answers as you go. Good luck with that. So hopefully you're feeling confident now with the straightforward trig practice, finding the length of missing side. Just before we go into exact trig values in more depth, I want to think about what we mean by a trig ratio. So here we've got three triangles, obviously not drawn to scale, and they've all got an angle of 30 degrees. Now, for all of these, we can see the relationship between the sides. So from the opposite to the hypotenuse, we're doubling it, or if we're going the other way, we're halving it. And we can see this holds for all our pairs of numbers here. Now, this is what we mean by a ratio. It's the ratio between the sides. And we can use it to answer questions like this. Well, if we're told this side is 35, we can see from the pattern here that the hypotenuse has got to be double that. It's got to be 70. And the reason for this, we're looking for sine of 30 degrees here. Remember from SOHCAHTOA, this is our trig ratio, and sine of 30 is equal to the opposite, which if we look at this first triangle is 1 over the hypotenuse, which is 2. So the sine of 30 degrees is a half. And it doesn't matter how long the sides are, it will always hold that the sine of 30 degrees is a half. So here we've got 3 divided by 6. Or here we've got 50 divided by 100. And if you do sine 30 in your calculator, it will just give you the value a half. So our trigonometry ratios are just the ratios between the length of the sides for a given angle. This one's got some slightly trickier numbers here, but we've got the angle of 50 degrees going on in all of these. Again, we're looking at the opposite and the hypotenuse. So we're still looking at the sine trig ratio. So we can see the sine of 50 degrees is equal to the opposite divided by the hypotenuse. So using the values for the first triangle, we get 0.766. Again, it holds for the second triangle. If we do 1.532 divided by 2, we get 0.766. So this is the value of sine 50. It's the ratio between the length of the sides, and because it's sine, it's the relationship between the length of the opposite and the length of the hypotenuse. So if we want to work out the angle the length of the side in our last triangle here, if we do 5 times 0.766, that gives us length of side 3.83. We've used the trig ratio for sine 50 to help us with this. Now the bad news is you need to know all of the values to fill out this table here. The good news is there are some pretty straightforward ways to help you remember it. If you search on the internet, there are lots of songs and methods with hands and different ways to remember the numbers. But those mostly rely just on rote memory, and there's lots of possible ways you can go wrong. The way I'm going to show you just using the square and the triangle we've got at the top is a really solid method, because you're not just remembering the numbers, you're not just remembering the order. It's a really good way to find out all these values in the table. So we'll start off looking at the square. So it's a unit square, so the sides are just 1. If we turn this into an equilateral triangle, we know we've got our right angle, so we can use trig on it. And we know these two angles here are going to be equal. They're going to be half of 90 degrees, so 45 degrees each. To help us find the ratios, we need to find the length of the hypotenuse here. And we can use Pythagoras to help us do that. If we square the length of the other two sides, we add them together, and then we need to find the square root. And that gives us the value here for the length of the hypotenuse. Now we're going to use this to fill in the values along this row for a 45-degree angle. We could use either angle, but just to hopefully stop a bit of confusion, let me get rid of that one and we'll just focus with the angle we've got here. So we've got opposite, hypotenuse and our adjacent. Remember from SOHCAHTOA that sine is equal to the opposite over the hypotenuse. So here the opposite is 1, the hypotenuse is root 2, so sine of 45 degrees is 1 over root 2. We can just leave it like this, but a useful way to recognise it as well is if we multiply the top and the base by root 2, then that's equal to root 2 over 2, and you'll often see it in this form instead. Cosine is equal to the adjacent over the hypotenuse, so that's also 1 over root 2, which again, it's really useful to learn to see it and changing it into this form where the denominator is an integer. Tangent is equal to the opposite divided by the adjacent, so that's just 1 divided by 1. And this triangle here gives us those values for an angle of 45 degrees. The equilateral triangle is going to give us the values here for 30 degrees and 60 degrees. If you're feeling confident, pause the video and see if you can work out how to get those from this triangle. What we need to do is we're going to split this triangle in half, and the equilateral triangle we want to be using has got sides of 2. So the right angle triangle we've now got here, the base is 1, and we can work out the height of it. We can work out the side here by using Pythagoras. So we do 2 squared, take away 1 squared, gives us 3. So the length of the side here is the square root of that, and we'll leave that in surd form. We can use this triangle to find out those 2 rows of the table. If we first of all start by thinking about the angle here, so equilateral triangle, we know all the angles in here will be 60 degrees. They'll all be equal. So we've got the opposite, the hypotenuse, and the adjacent. If I just fill in the values for those we've got from our other triangle, and now we can fill in this row for angle of 60 degrees. So the sine of 60 degrees is equal to root 3 over 2. Cosine is equal to 1 over 2, and the tangent is equal to root 3 over 1. We can just leave that as root 3. We know the angles inside the triangle are all 30 degrees. So we've split the angle at the top in half, so this is now 30 degrees, which gives us the opposite here, the hypotenuse here, and the adjacent here for our right angle triangle. So sine is equal to the opposite over the hypotenuse, so that's equal to 1 over 2, just a half. Cosine is equal to the adjacent, which is root 3 over the hypotenuse, so root 3 over 2. And the tangent is equal to the opposite divided by the adjacent, so 1 over root 3. Again, when we have a surd for the denominator, it's worth multiplying top and bottom by that surd. That gives us root 3 over 3. So we've got 9 of the values in our table filled out just by using this square with sides of 1 that we split and make the isosceles triangle. And then we've got our equilateral triangle with sides 2. To work out the values for 0 degrees and 90 degrees is a little bit trickier. But what we need to do is to think about this triangle here. So this is our angle. So we've got the opposite, the hypotenuse, and the adjacent, which you can see we've given a value of 1. Now, imagine with this, if we're squeezing down the opposite, so the angle's getting smaller and smaller, and eventually get to a point where the angle is 0 degrees. Now, it's a bit weird thinking about this, because if it's 0 degrees, we're not going to have a triangle, we're just going to have a straight line. But just imagine it as it gets smaller and smaller, because this will help us work out those values. So sine is equal to the opposite, which as this is squeezed to nothing is just going to be 0, divided by the hypotenuse, which is going to be 1. So that's just equal to 0. Cosine of our angle is equal to 1 divided by the hypotenuse. And tangent is equal to the opposite, which is 0, divided by the adjacent, which is 1. So that's going to be 0. Think about the same triangle, but this time the angle we're interested in is up here. So we've got our opposite down here this time, our adjacent and our hypotenuse. And again, I want you to imagine it being squeezed down. So the adjacent in this example, the right-hand side is getting smaller and smaller. So our angle is going to be getting closer and closer to 90 degrees. So again, I know it's a bit weird thinking, well, if it goes all the way down and that's 90 degrees, it's just a straight line. But it does help us, this thought process, get the values we need for the table here. So sine of 90 degrees is equal to the opposite, which is 1, divided by the hypotenuse, which would also be 1. The cosine is equal to the adjacent, which will be 0, divided by the hypotenuse. So that's just 0. And the tangent is equal to the opposite, which is 1, divided by the adjacent, which is 0. Now we can't do this. We say this value is undefined. And that's not the same as saying it's infinite. Because remember what division means. We're saying, so if we could do 1 divided by 0 and whatever number came out of that was x, what this is saying that x times 0 will equal 1. Okay. Now, there's no number that if we multiply it by 0 is equal to 1. So that's why we say this is undefined. So there is a lot to remember in here. I wish you didn't have to remember this for the GCSE. And it doesn't come up that often. But I'm really hoping the way I've talked you through this will help. Like I say, there's other ways to remember it, songs and finger tricks and all sorts of stuff that you might want to check out. But I do think this is the most reliable from work I've done with students before. Now, your job here is to pause the video and do your best drawing out this table and filling in all the values using what you've just seen. Good luck with this. Flick back and forward as you need to. It will be really useful practice. Just sitting and watching it and having it flow over you, it's not going to help it sink in. You do need to do this for it to make more sense, for you to remember it better. Good luck. So we're going to test here, possibly your memory a bit, but certainly those skills that you've just practiced by doing a bit of trig, but not using a calculator. So we know how to start. We've got to label the sides here. So we've got our opposite, we've got the adjacent. And we know from SOHCAHTOA, for this we need to use tangent. So the opposite, x, is going to be equal to the tangent of 30 degrees multiplied by 7. So now the challenge is, can you remember what tan 30 is? I can't, but I can remember if we do the equilateral triangle with sides of 2, and then we chop that in half, so that side's 2, that's 1. We can work out the height of it. We do 2 squared take away 1 squared, which is 3, and then we get the square root of that. And for 30 degrees, we're looking at this split angle at the top. And tangent is the opposite, so that's going to be 1 divided by the adjacent, so that's going to be root 3 times 7. So just sketching this triangle quickly is enough just to remind you of what this value needs to be here. So tidying this up, we can write that just as 7 divided by root 3. And generally, if our denominator is a surd, then it's really useful, multiply top and bottom by that surd. So we'll get 7 root 3 divided by 3. It's generally more useful to leave it with an integer on the base. Second example, so we've got the hypotenuse and we've got the adjacent here. So we need to use cosine for this. And working out the hypotenuse, we've got the adjacent, which we're given as root 3 as that third exact value, divided by the cosine of 45 degrees. So again, the challenge is, can you remember cosine 45? I can't, but I know if I draw our unit square and split it into an equilateral triangle, For cosine, if we use this angle here as our 45-degree angle, we've got the adjacent, which is 1 divided by the hypotenuse, which is √2. So cosine 45 is equal to 1 over √2. Now, putting it into this can be a little bit confusing, starts to look a bit messy, but let's think about how that fraction line just means divide. So we've got √3 divided by 1 over √2. And if it helps, we could change this into a fraction, just putting it out of 1. Remember, if we're multiplying fractions, we keep the first, we change the sign to a multiply, and we flip the second. So here, remember with our surds from the start, we're going to multiply these. √3 times √2 is the same as the root of 3 times 2, same as √6, just divided by 1. Have a go with these two examples. It is worth drawing these little triangles to help you remember. The more you practice that, the more you'll be able to, just say an exam question, just be able to come up with those values when you need them. So here we have our opposite and hypotenuse. So we know from this we need to use sine, and the hypotenuse x is going to be equal to 5 divided by sine of 30 degrees. So again, we can do our triangle. We know for 30 degrees it's this one that we want. You might need to think through a bit about how we got those values on there. So we need the opposite, which is 1, divided by the hypotenuse, which is 2, just a half. So we've got 5 divided by a half, which gives us 10. Last example here. So opposite, adjacent, we need to use tangent for this. We know that the adjacent is going to equal the opposite, which we've got here in surd form, divided by the tangent of 60 degrees. And we need to remember what's going to help us find the tangent of 60 degrees. So we're thinking our equilateral triangle, that's been split in half. And remember the height of it is √3 because we square 2, take away square of 1, and then we square the answer to get √3. 60 degrees here. So for the tangent of 60 degrees, we need to do the opposite √3 divided by the adjacent, which is just 1. So that's just equal to √3. So we've got 3 √3 divided by 3. And we can simplify this. If we divide top and bottom by √3, we just end up with 3 over 1, which we can write just as 3. Hopefully these are making a bit of sense. Hopefully you're not being too tempted to use your calculator and you are working out these values. Like I said, just doing these little triangles each time will help you to remember the process for this. Last thing today is this task here. So the examples you've just done are 4 of the questions from the sheet. You need to work out the length of the missing side, and then you need to fill it in as part of a code breaker. Just be careful. If you get an answer like one of the answers we had on the last sheet was 7 over √3, and you look down through all the possible answers and you can't see it anywhere, remember, if we multiply numerator and denominator by the surd we've got on the base here, we get 7 √3 over 3, and you will be able to find that in. So just watch out for that as you go. You might be able to rely on this by just remembering the values from the table, but just quickly sketching those triangles. The more you do it, the better you get at it, the more it will become second nature. So stop the video. This is the last thing you need to do to fill up your hours lesson today. In our next few lessons, we're going to continue with trigonometry, but not with these trig ratios you've seen before. We're going to be looking at some new trig rules that you haven't seen before. And these exact values we're practicing today are going to come in handy, and we'll get lots of practice using those.